Okay. So we were talking about SQL scheduling, right? Okay. So in just a high level, like I'll just touch base what we have. Um, SQL scheduling. Scheduler is a logical layer at the SQL server, whereas it is mapped to individual physical CPU, right? SQL Server uses a SQL Server own scheduler to schedule the threads. The reason that we have, because we will not span all the threads, will not spawn all the threads to the Windows server, right? So you have a Windows operating system, you have CPUs, and we are not spawning all the threads at the SQL server side. So we will not spawn all the threads, right? So it causes the performance impact of the system. So one impact is context switches. You'll have high context switches because you are spawning entire threads to the Windows operating system. Instead, SQL operating system, what it does, only one thread it's sent to the Windows operating system, and remaining threads will be in the SQL OS itself, right? So as soon as the thread is coming out of CPU, this will give a signal to the thread which is currently in the runnable list, right? So then the thread which is in the runnable queue will go and start executing on the CPU, right? So as soon as when this thread will come out of CPU, this thread will come out of CPU if it is so SQL thread, and if it goes to the SQL OS back, then there are certain reasons. One, if the thread execution completed, and second thing, if the thread needs some resources, right? If the thread needs some resources, then it will go out of CPU. Third one, um, there are Microsoft developers, right? I told you, like there are some yield points Microsoft developer has set. So if we meet that yield point, if the SQL code, what we are executing, it met that yield point, then it will come out of CPU. These three way, the thread will come out of CPU. But in a Windows, within the Windows server, the slice is still applicable, right? 4 milliseconds slice, whatever that we have, is still applicable, right? As soon as the 4 milliseconds is completed, it will come out of CPU, and the thread is still be available in the Windows operating system, and see if any other threads are in the queue. Though we are not spawning entire threads, there are chances the same system can have multiple applications or multiple processors, right? Let's say, for example, Notepad, PowerShell, whatever it is, and it also can spawn some thread, right? It checks whether if there is any other threads are in the list or not. If no other threads within the kernel, so the same thread will continue executing, right? So this is how the works. So in SQL Server, we have a different queues. One is writer queue, IO list, timer list, right? So IO list. Yes. Okay. So IO list, timer list, timer list, IO list. What else? Like, so in the runnable queue that we will have, and thread pool. Thread pool is just basically a uh, pool of threads, right? So it will be taking, as soon as a new task is created, a thread will be assigned from the thread pool. Available thread will be assigned to thread pool. So then it will be in the right end of the runnable queue, right? End of the runnable queue, so that it will wait for CPU to be available. as soon as the thread is one thread is coming out of CPU, it will give a signal to the thread which is in the runnable queue, and the thread will be start executing on the CPU. That is what we call it as a cooperating scheduler. So that is what it is, cooperating scheduler, right? So now I tell me one thing. Let's say, for example, I have a blocking. So I need you to answer. So I have a blocking. So if I have a blocking, so would that cause the high CPU? Yes, why? No, why? Based on this understanding, so if I have a blocking, so what would happen and whether would it cause that high CPU utilization? Yes, no, whatever. Like, okay, fine. So, if there is a blocking, right? So it should not cause any high CPU because the thread, the high CPU we would see only if the thread is currently running on the CPU. If it is blocking, the thread needs some resources, then the thread, whatever it needs resources, it will go out of CPU, right? So that will go out of CPU and it will be in the runnable queue. It will be in the waiter queue because it is waiting for some resources. As soon as the so resource it receives, then it will start executing on the CPU, right? So just for your information, if there is any blocking, we no need to investigate the CPU utilization because so definitely we will have to look if there is any high long running queries or anything on the CPU which cause the blocking, but the other queries which are blocked would not take any of the CPU cycles, right? Right. This is what we discussed, like whatever operations, whatever the states of the thread, right? So let's say if it is a timer thread or IO list or it is in the waiter list. So whatever list that we have, so if the thread wants, so if the thread has to execute on the CPU, it will go to the runnable queue, and from there only it will go and execute on the CPU. It will go and execute on the CPU. Right. This is how it works, right? So it will go and so place it in the end of the runnable queue, so that whatever thread which is in the list, which is in the first runnable queue, it will go and execute the thread. These are the states, right? Suppose if you see whatever we have it here, this is only the thread which takes the CPU utilization. This is only the thread which takes the CPU utilization, right? So if it come out of CPU, it might not take the CPU utilization, right? It will not might, it will not take the CPU utilization because the thread is coming out of CPU, right? So if the thread is waiting for something, then it will be a suspended state. If the thread is currently in the runnable queue and waiting for CPU to be available, so it will be in the runnable list. If the thread is doesn't have any, so if the task doesn't have any thread to be assigned, then it will be kind of pending. So if the session is in sleeping state, it will be in sleeping, right? So if the thread is sleeping, then it will be sleeping. Let me show you that. For example, begin run. Okay. Last minute. ABC. Let's see. Okay. Let's see. These two are executing, and let's see if any other sessions which is blocked. So 73. SP underscore who 2. I can check 73. Is blocked by 69. What is the 69? Hmm. Okay, whatever it is, right? So 69 is blocked. So instead of this, so it's okay. If you see the status as suspended. So if you see the status as suspended, the session is currently suspended state. It is not doing anything. It is just waiting for some resources to be available, right? So what is the resource it is waiting for? Like this is a lock resource. That is where we see that blocking, right? So if I execute begin run, okay. So data we got some data, right? If I take the same here and new query window, sp underscore who to 75, the session that I am executing select statement, which is currently in sleeping state. So it is not doing anything, right? So if the session is in sleeping state, we are sure that the thread is not doing anything. So it will not take the CPU cycle. So I have to check that select start from sys dot sys processes where speed equal to 75, right? So if I take mm, if I take that CPU comma status, right? So we will talk about the DMVs and all just for your information, right? So if you see that CPU time is currently stuck, it is not stuck, currently static, right? So it is not moving forward, right? So that is where it is. If it is sleeping, the thread which is currently not doing anything, right? So not doing any CPU cycles, right? It is not taking any CPU cycles to execute or to run this thread on the CPU itself, right? So we just came out of CPU and it is in sleeping state, right? It is not doing anything. So likewise, if I take this 74 or 70 speed in 74 comma 73, right? If I take this and it is waiting for some resources, what is that resource? It is a so some page, right? So table lock, right? So tab is table lock. Like we will talk about the locking. Don't worry for now. Just understand this is what it is. Fifth 5, so the database ID 5 and the table ID, right? So 2085, whatever it is waiting for. It is acquiring a lock on it. And then it is not taking any of the CPU cycle. So CPU is 0. It means it is not even triggered to execute on the CPU. So it is not doing anything, right? So you don't see anything which is changing, like only except this open transactions and blocked, you will not see anything additional in this, right? So if the query is running slow, then you'll have to first check that whether the blocking is acquired or if there is any current blocking or not, right? So this is for your information, like we will talk more in detail, right? So this is how the states of the thread would be, right? So whatever pending that we see here, if the thread doesn't have enough, if a task doesn't have a thread, right? For example, if the task doesn't have a thread, it cannot create a session, because as soon as it assigned to a thread, then SQL Server will create a session for the execution. Then how you will monitor that? So whatever pending that we were talking, right? Select star from sys dot dm underscore os underscore waiting task, right? So if you execute this waiting task, I will go with, okay. So if I execute this waiting task with respect to of the CPU creation, right? For example, this one CPU has not created. So you will have this, the thread information, the session, you'll have that information here in the OS waiting task. For example, thread is not available. So it is waiting for thread pool. If the thread is waiting for thread pool wait type, then the thread is not currently executing. It is stuck in the queue, right? It is stuck, or it doesn't have enough available thread to assign to that particular task, right? So that is where you will see, and you will not see a session because session would not be even created. This is some internal background threads, just is showing, but the value and details would be same. If the user session or user task doesn't have enough threads available to pick the task, then the session would not be created. But it will show this here in the OS waiting task as pending, and it is waiting for thread pool wait time.
Sorry, can you just talk about the null again? Sorry.
Sorry.
Can you talk about the null again? You said something about the null that I don't know, maybe I didn't hear very well. If it doesn't have enough resources, so why are we seeing the null?
This null. Okay.
Yeah.
Okay. Okay. Just a moment. Right. So if you see that, right, whatever incoming request that is coming in, so if you see that incoming request and it checks whether the idle thread is available or not. If the thread is available, and it will assign the thread and it will be processing with that, right? So if the
Okay.
thread itself is not available, then it cannot create a session also, right? If the thread is not available, so it cannot take the task, and even session would not be created, right? So
Okay.
session as in like SPID, whatever we are talking, so it would not even create. If the session itself is not creating, then you would not see the session ID in the sys.dm underscore OS waiting task. So only DMVs that we can see, sys.dm exec request or sys.sys processes, if the session is created, if the task is assigned to a thread, and the thread is currently either waiting or whatever, suspended, sleeping, whatever it is, if the thread task is assigned to a thread, then you can see there. If
Okay.
once the task is assigned to the thread will be, then it will create a session. So SPID, then only you can
Okay.
see the SPID value. If the SPID is not created, you would not see that SPID here, but it will be waiting for some wait types. Let's say, for example, thread pool. If it is waiting for thread pool, The thread is not even assigned to a task that we have. So this is the waiting task. So this is the tasks information which is currently waiting. So whatever sessions assigned or not, the tasks are waiting for some resources.
Okay.
Right.
Thank you.
Sure. No problem. Right. So okay, let's move forward. Right. So performance tuning cause map. Right. So this one. So any performance tuning, right? So there are divided into two main sections. One is the query performance. Second one is the overall server-wide performance, right? Say for example, query performance, a specific query that we will have to troubleshoot. Let's say the entire server performance, right? So it can be entire overall server performance. It can be IO, it can be memory, it can be TempDB, it can be high CPU utilization, it can be storage, whatever it is. Like this is all comes under one category called query server performance, right? So we will have to investigate. Let's understand just this is just a high level cause map performance issue, and we'll have to see if there is any specific query is running slow, right? So we can ask application team, so what is the issue, right? So they'll have to confirm like whether it is a specific process or specific query is running slow, or the entire process is running slow. So based on that, we'll have to look, we'll have to investigate further, we'll have to troubleshoot further, right? So specific query, if not, then check if there is any configuration issues, right? Configuration, as in like last time that we were talking, right? So in the configuration side, so we'll have to see if there is any issues with the configuration. Let's say lock pages in memory, or if it is if it is instant file initialization, or if there is any issues with the server level configuration like max server memory configurations, or if there is any issues with the optimizer for ad hoc, in any configurations which are not optimal, right? So we'll have to reconfigure and reconfigure the configurations, right? So then health check or server wide performance, right? If there is no issues with the configuration, then it will go with high level health check of the server wide performance, like CPU utilization, anything on the server side. So we'll have to start looking at, right? So complete overall performance of the server, right? So if a specific query is slow, that we know it, if it is a specific query is slow, so identify the query statement. So we'll have to see if the query statement is identified or not. So what does it mean? If you are executing as a batch, right? So you are executing as a batch and our job, let's say, whatever. So if a batch, I mean, so if a batch or a job can have multiple statements in it, right? So can have multiple statements, like whatever it is, can have multiple statements. If the entire job is slow, let's say you have two statements here, and one statement is running, the overall job is executing 10 minutes, let's say, and this one is taking around 8 minutes, and this one is taking around 2 minutes. Then we'll have to, so see which statement is running slow, that we know this statement is running slow. Then instead of troubleshooting the entire batch or the transactions that we have, so we can pick this statement, particular statement or particular text of the query, and check further what is the issue, or whether the performance issue for that particular query, particular transaction. So instead of troubleshooting the entire, one second. So instead of troubleshooting the entire batch, so we'll troubleshoot or we'll look only that particular statement.
Then one question.
Yes.
my my one application or my one query is giving the certain the data correctly, but sometimes some column data is missing permanently. Is missing the some column data where you put say server performance or query performance.
And I didn't get you. What was that?
I am a query where I am inserting the data
Hmm.
in 20 columns,
Hmm.
perfectly working, but sometimes one or two columns data is not capturing there.
So you mean that you have, let's say, for example, four columns and you are executing a query and sometimes the data is not fetching
Oh no, not select. I am inserting the data.
in certain data. Okay.
Okay, so mostly time it is working perfectly. Only. But sometimes only I seen that one column is missing the data. In three column data will be available, but in one column data will be not available.
Okay.
Where we put this query issue or performance issue.
No, it is a query issue, right? It is not performance issue. If you are inserting data, let's say for example, you have a four columns, so like ID, name, whatever it is, four columns, and you are inserting data. So while inserting data, so you'll have to pass the four column values, right? So whatever we are passing, so we'll have to pass four column values so that the four column data will be inserted. Now you are executing that and you are not getting the data. If you're okay, two things. So one, either data missing or data is not available. That is where that so it is it is not an issue with the performance, right? So but second thing, if you're running a query, either whatever query that you are executing, it is taking time, so to get the result set, that is what we call it as a performance. If the data is not available or data is missing, that is something that so data integrity or data issue, or even the table or query issue.
I have suppose that I have one query. I am inserting same data every time,
Hmm.
but sometimes one column or two column data is missing.
So what do you mean by missing? I didn't get you. What do you mean by
It is
missing?
not capturing in table.
Not inserting into a table?
Yeah,
No, if you're not inserting, if it is not inserting into the table, uh, I don't know, like what is your query and how you're inserting, that matters, right? It is not that performance issue. If the data itself is not inserting, so what we do, right? So whatever queries that they are that we are executing or they are giving, so that is where we will have to look into.
suppose that like that I have one statement insert into table XYZ value 1, 2, 3, 4.
Mm,
Correct?
mm.
I am running continuously this query statement. But sometimes last column number 4, not getting the value of 4. Query is saying it is perfectly working. There is no issue with query.
Mm. So, okay, maybe we can talk that later. That if the data is not retrieving or if we are not getting the data, that is not a performance issue, for my understanding. Like, so you'll have to understand. Otherwise, maybe we'll have to see what and how you are executing the query. That matters, right? So we cannot, so conclude that it is an issue with the performance, because if you're not getting the data, I don't know what you do, like if you're not getting the data, right? So you'll have to look into that if you're executing a query and you're not getting data, and you'll have to check the data side, right? So not the performance side, right? Right.
Thank you.
So mm, right. So let's say, for example, if you trouble if you're so executing a batch, and if you have a multiple batches, then you'll have to have multiple statements in it, like you'll have to identify which statement is running slow, right? So which statement is running slow, so that you'll have to troubleshoot that particular statement or the particular query, right? So now uh, if the query is identified, the statement is identified, then we'll have to work on fine tuning the query, or we'll have to work on query performance, right? So for example, query is running slow. Either it could be an index required or statistics, whatever it is, and we need to investigate the particular query. If the query is not identified, then we'll have to start working on capturing some traces. Either it could be extended events or it could be a query store or profile a profiler in that matter, like, so DMVs, whatever third party tools, like whatever that we have. So we'll have to use the tools to identify the statement, identify the query which is running slow, right? So we'll have to work on it. So we'll have to look into it. Okay, one second. So these are all we already discussed, like server level basic configurations. Like I will just skip that. Now, so let's say weight statistics, right? So weight statistics. So what are all weight statistics that we have, right? So whenever there is a query, whenever a query is running slow. So when if a query is running slow, so only two things we'll have to look into, right? So anything, right? Not only query, anything that matters. If it is slow, that we'll have to understand two things. One, what is the baseline of the particular query, right? So particular query or particular system, right? So based on the baseline that we will have to proceed. So either do you have a baseline or not, right? So that is what it is. So what performance problems, right? Show me your baseline. So we'll have to understand the baseline. So what does it mean by baseline, right? So let's say, for example, yesterday the query was executing fine. So, but today there is a slowness. Does it make any sense, right? So if you say that yesterday was running fine and today is slow, so what do you mean by slow? So what is the baseline? So what is the baseline? So how much time it took yesterday to complete the query, right? So let's say, for example, yesterday it was for 1 second. Yesterday it took around 1 second to complete the query. Now it is taking around 10 seconds. Now the same query is taking 10 seconds to complete. Then this is the baseline that we will have to look into. So if 1 second was executing, now it is taking 10 seconds, we'll have to start looking at the difference, right? So why, how it was taking 1 second and now why it is taking 10 seconds to complete the query, right? So based on that, we'll have to investigate. This we call it as a baseline. Second, right now we have a baseline. Second point, if this query is taking 10 seconds, whether this 10 seconds the query is running or waiting for resources. Runner query or waiter query, right? So if the query is waiting for some resources, it will not be running on the CPU. It is in suspend state and it will be waiting for some resources. If it is running query, the query is currently executing on the CPU and taking more time to execute. So we'll have to start looking at that particular query. So either the query plan has changed or whatever it is. So we'll have to look into that particular query performance, right? So if the query is waiting for some resources, we'll have to look at wait types, what it is waiting for, what resource it is waiting, and we'll have to look into that wait types that we have, right? So let's go on with the wait types that we have. No baseline, no performance. Let's say we don't know yesterday execution or we don't know previous execution. So if you don't have that information, the previous execution, we can just so work on just the current metrics. That's it. So we don't have a baseline, so we cannot confirm that whether this will be matching that whatever the expectations. Let's say you don't have a baseline, but users are telling that this should be executing within 1 second. Now it is taking 10 second and it should complete in 1 second. If there was no baseline, then you cannot match their expectations. So we can tell that, okay, this might not be case here, like it might not be, since you don't have a baseline, then we would not be able to, if you don't have a baseline, then we would not be able to match the expectations that we have, that you have, right? So you don't have. Okay, so this is the query life cycle. So whatever queries which are coming, which are executing currently, which are running currently. One second. These are all interlinked, right? So if the query is running slow, right? So either it is waiting for CPU or it is in a runnable queue, that is in a signal wait type. So there are two types basically. So the CPU time, right? So signal wait time and wait time. So whatever we are executing, so let's say for example, the query is currently executing on the CPU. That is the actual execution time, right? So actual execution time. Suppose if the thread is suspended and waiting for some resources, the resources can be anything, right? That will be a wait time. If the thread is not waiting for any resources and it will be in the runnable queue, that is what we call it as a signal wait time. The reason we call it as a signal wait time, because I was talking about the cooperating system, and the thread which is currently running on the CPU will give a signal to the thread which is in the runnable queue, right? So how much the thread is currently in the runnable queue, that that long you will see, that high you will see the signal wait time, right? So these are the all dependent, right? So if the thread is currently running, you will see the CPU time. If the thread is currently so waiting for some resources, you will see suspended, right? So it is blocked or suspended, whatever it is. Then thread is currently in the runnable queue, waiting for CPU to be available, right? So this is the waiting for CPU and waiting for the resources and actual waiting. So what does it mean? I will explain. Right. So if the query is running query, then it will take the CPU. So when that CPU time it takes, like if the query is executing or if the query is compiling, right? So compilations and the execution require some CPU cycle to process, right? So if the query is waiter query, right? If the query is waiter query, then it will be waiting on one of these resources. Either it can be a log or it can be IO, network, whatever it is waiting for all these resources. So let me put all together, like, so whatever that we have it here, right? So what does it mean? Let's say, for example, you will have one query. Let's say, for example, CP select star from table. Select star from table, you are executing. This table takes around 10 seconds. 10 seconds to complete the query, right? So after this 10 seconds, let's say, for example, actual execution on the CPU is 1 second and 7 seconds it is waiting on some resources. Let's say, for example, log waits, and 2 seconds is in runnable queue and waiting for CPU to be available. Some other thread which is currently running, and we know, right? As soon as it acquires the log, it will be placed in the end of the runnable queue. So it has to wait in the runnable queue until and unless it gets its chance, right? That is how that works. So this is how that works. Now, so this one, whatever query is executing, So this all completed all together, the time it took around 10 seconds. This 10 seconds, we call it as a total duration of the execution, right? So total duration of the execution, the query. Total duration of the query or elapsed time. So if you see that elapsed time, so elapsed time is total complete duration of the execution. So including the thread which is currently running on the CPU, including the thread currently waiting for some resources, including the thread which is currently in the runnable queue and waiting for the CPU to be available. So this is what we call it as a duration of the execution. If I take that some any random uh, queries and everywhere you'll have that um, let's say for example select star from sys.dm exact request where session id is greater than 50 for example, and if you see that here CPU time, how much time it took to execute on the CPU, what is the total elapsed time. So total elapsed time is the total duration of the query, right? So you will have that total duration of the query, right? So based on that, you will have so the total duration and how much time it execute on the CPU itself, right? So you will have that info here, right? So total elapsed time is this because the thread is currently whatever, right? So it is not taking any CPU cycle and which is currently executing on the system, right? So that is what it is, right? So this is the total elapsed time. So if you are troubleshooting any of the queries, slow running query or any of the queries that we are working on, and you'll have to identify what is the CPU time and what is the duration. If you have a less CPU time and more duration, then that is where the query is waiting for CPU to be available. Now, so any chances, so CPU and duration I was talking, right? Duration equal to CPU time plus wait time plus runnable wait time, whatever we call it as, right? So runnable wait time, right? Wait for resources and waiting for CPU, runnable time, right? Signal time. So you can consider that signal time, right? So now this duration is a combination of all these three. Now, if you want to identify the CPU, the duration minus wait time minus signal time, you will get the CPU, right? So you will get the CPU. So based on this, we understand always CPU will be less than the duration value because CPU is one part of the part in the duration. But you think anywhere you see that CPU is more than duration. So anytime you think that CPU time is more than the duration that we have. So the duration is nothing but overall execution time, right? So any time that you can think CPU time is more than duration is only, yeah.
When it's not hidden.
When is not what?
When the task is not hidden. So when it's in the processor but it's not hidden.
Not yielding.
Yes.
But still, like if it is not yielding, then the duration is, so this is just a addition to the CPU, addition to the existing parameters, right? Like say, for example, duration and CPU plus wait time plus signal time, right? If the thread is currently running, let's say, for example, it's currently running on the CPU and which is not yielding, let's say 10 seconds, which is not even yielded, then the duration is always more than 10 seconds, right? So because it will have addition to this, right? Whatever it is, either it is 0 plus 0, then duration will be 10 seconds at least. So when the CPU will be more than duration. So duration is just equal to addition to the CPU, right? Whatever CPU that we have, addition to that CPU. For example, let's say what my question is, let's say duration, you see that 10 seconds, but the CPU 20 seconds. Is it possible? Can CPU can have more than duration? So only one way it is possible. Any guess, like, so when the CPU would be more than duration? Only if the query is running parallelly, right? So if there is a parallel threads, so each thread requires some same amount of CPU cycles, right? So if the thread is running on multiple CPUs, the overall duration would be much more less than the query that we are executing. So if I take any this processes where session speed equal to 77. If I execute this, block by 51. What is this 51? And select star from C1. This is completed. Okay. So this will remove the pages, drop clean buffers. It will, whatever the clean pages that we have in the memory, it will drop those clean buffers, right? So just wanted to show or see. Oh, okay. What I'm doing. Mm, Order tracking. Okay. select star from order tracking. So if I take that, select star from sys processes where speed equal to 63. I execute this. If I execute this, I think this is completing quickly. That's fine. Okay, I'll see, right? So whatever threads which are executing, if I take that, current waiting task. Okay, so this is not the one. That. Okay, so what I was trying to show, like, so see if I can spin that, so parallelism and get the query, get the execution. But I'll show you that later. But for now, understand if the CPU is more than the duration, if you notice anyway, like if CPU is more than the duration, then the query is going for parallelism. And if the query is going for parallel execution, then each thread will take the same CPU, same amount of CPU cycle. So that is the only reason. If you would see the CPU is higher than the duration that we have, right? So that is what it is, right? So whatever. So whatever we see here, so that is, so that is what it is, right? So the signal wait time and the wait time that we have, and so the whatever like CPU time that we have. CPU is actually currently running on the CPU. Signal is if you have a high signal wait time, that is where you'll have to check, like, so if the query is running slow, or if any existing query or which is currently running on the CPU is taking more resources or more time, right? So you'll have to look into that. And wait tab, and if the query is suspended and waiting for some resources, and we'll have to look into it, right? So query is running, and if the query is compiling and executing, it takes some CPU cycles. That is what it is, runtime. And if it is query, if the query is waiting for some resources, and then we'll have that, so one of these wait resources that we have, right? So we are going to talk this section to understand that wait types, right? So we are going to talk that. Right. So here, this is what it is, right? So wait statistics. So wait time, the thread is waiting for some resources, right? So either it can be a blocking, lock, page, whatever it is, and thread is waiting for some resources. And what is the cumulative wait time, right? So wait time since the service or server is restarted. So what is the cumulative wait time? The since the service is restarted, so what is the total wait time of that particular resource, right? So cumulative wait time is total wait time since the service is restarted. Signal wait time, a thread in the runnable queue waiting for the CPU to be available, right? So that is what it is, signal wait time. Total wait time. So total wait time is nothing but the wait time plus signal wait time. So wait time, that is waiting for some resources. The signal wait time is called the total wait time that we have, right? So let me see here. So wait statistics. Okay. So if I take this, right, so this top weight types that we get, right, what are all top weight types that we have from the, so DMVs that we have. So you will get the top weight types, So based on what? So what are the tables which are using? If I take this sys.dm underscore voice weight stats. So what it gives, right? So it tells that the historical weight types. Let's say, for example, uh, some weight type like the queries are waiting and you don't know, you are not there during the time of issue, and you want to identify the historical weight types. What was the historical weight types which are consuming more resources or highest weight types, right? So you can get these to get the historical weights, right? So that's what it is, the historical weights from DMOS weight stats, right? So that gives the historical weights. And if I execute this, these are the weight type and how many weights it is, the total weight count, right? So total weight time, right? So this is the total wait time I was talking, right? So it is the signal wait time plus so resource wait time, right? So these two are combined to have this total wait time, right? So this is the average wait time that it is waiting for, on an average how much time it is waiting for, right? So average wait time is in milliseconds, whatever. Um, right? So average resource wait time, whatever it is, and the percentage of wait time, right? So running percentage and percentage of wait time, right? So how much is the so total run time. So what is the percentage of the wait time? Is 33% it is waiting for something, right? So this is where you'll have to look into that. Why it is waiting for most of the time, why it is waiting for some resources, right? So that is where you'll have to look into it. The wait time that we have. So I will have this, so the queries to look into that from Git. I'll share that, so with you guys. So we have two main DMVs to look at the wait times, right? So one is sys.dm underscore voice waiting task, and second one is sys.dm underscore voice wait stats. So based on these two DMVs, we will have to investigate the issue further, right? If the if you have a current live troubleshooting, if there is an issue with you'll have to investigate the live troubleshooting, then you'll have to use the system underscore OS waiting task. And if it is current or historical waits and you want to postmortem the issue or debug the issue, and you can use the system underscore OS waiting stats. So based on this we can identify the highest weight consuming queries. Let's say, for example, if I take that current waiting task, right? So this will give us sys.dm underscore OS waiting task, right? So based on this, so we get the data. If it is waiting for some resources, let's say, for example, begin tran person dot person. Okay. Section, so let's take this and go here, new query, execute, new query, begin run, update, set last name equal to ABC, execute, copy, XYZ, execute, something we are executing. And we want to identify or investigate the current wait types, current wait time of the query that we have, right? If I execute this, you will have the blocking session ID. What is the blocked session ID? right? So what sessions which are blocked, right? So 83 is the blocked. So what is blocking? 69. So that information you will have. No, don't worry about the lock block and all. So we will talk details. So for now, just understand that what is the wait duration and how to get the information of the so current invest live troubleshooting of the issue and what is the waiting for, which resource it is waiting for. So you'll have that information in the sys.dm exit, sorry, sys.dm underscore voice waiting task, right? So from there we can pull the data. Historical waits and track cumulative updates that we have. So these are all common wait types that we have. Okay, a second. Yeah. So any questions? So I have some work, like maybe I'll have to wrap for today because I'll have to jump on another call. Like I'll have to uh so finish up anything. So you have any questions?
I'm just going to ask: are we going to get these materials?
Sorry,
Are we going to get this slide? This slide.
this one, yeah. So I'll share, but not immediately or something, like we will share these slides. Uh, I'll convert this into PDF and I'll share that. Yes,
Okay, that will be fine. Thank you.
sure. Cool. So any questions on this, right? So we will talk that what are the common DMVs. You tell me, like, so in your maybe some like so working, right? So like what weight types that you have noticed, or what are all weight types that we have, or that you have noticed in your day-to-day activity or day-to-day uh, so troubleshooting SQL Server, what weight types that you noticed?
May I have a question on this cumulative wait time? So you said it's the time since the service was restarted. So it's not specific to a thread. It's just like combination of all the wait time from when the service was started, right?
Correct.
Okay. So what does that information help with in troubleshooting, since it's not particular to a query or a thread or something?
This is particular to this is not particular to query, but particular wait type. For example, let's say you want to investigate the overall performance of the server, right? So
Right.
you don't know where to look into, then maybe you can look into that cumulative weight types, or what are all top resource consuming weights on the system. Let's say, for example, uh, here that I was talking, right? So this is the total weight type. So this will give you the cumulative weight type of the resource, right? Let's say, for example, you want to investigate some issue. So these are all not considerable weight type, but if you see that like page IO latch or page latch, or
Yep.
if it is some other noticeable weight type, then you'll have to see like what is the percentage these are consuming, right? So based on that, we'll have to see, like for example, CX packet, just an example. So if you have a high parallelism on the system, then you'll have to understand that okay, there is a high parallelism on this, and we'll have to keep a track on it, right? Either it is a impacting performance, or with either it is a better execution. So it helps to identify the overall server performance, not a specific query performance.
Right. Okay. And is it possible to get the scripts that we've used
Yes,
so
yes,
far?
I'll share that. I
Okay.
can ping you here, like, but I'll share that complete scripts on the Git repo. So I have that Git repo, and I'll share that complete Git repo to you guys to look
Okay.
into. Right. So any questions on this so far? So I was
Yeah,
also
I have a question on the wait type. How do you troubleshoot write log?
ah we will work on it, right? So we have some like so the weight types, that's what I mentioned here, but we'll look into that. So write log. So can you tell me like what is write log, or what is your understanding of the write log? I believe that I have already touched base while we were talking about the architecture, but what is your understanding of the write log?
I know it has to do with the transaction log. So but it's just a basic knowledge on it. But I've seen that weight type at work, and I've asked question on how to go about it. He said he has to. But I want you to explain it your own way. I don't want to rely on what they told me on how I figured it out.
Sure, sure. Yeah, we will talk that. Write log is basically writing into the transaction log file. That's it. So whatever data which is whatever DML operation that you are performing, and it will be first initially stored into the log cache within the memory. From log cache, it will write periodically to the transaction log file. That is where you will see that write log. There is a write log writer thread. So where it will write that information into the transactional log file. So that is where you will see that write log. So maybe you'll have a high transactions which are frequently committing and writing into the transaction log file, and you'll have that buffers will be flushing frequently, right? It will be writing into the transaction log file. So that is where you'll see that high write log. But we will talk about, so how to mitigate and how to reduce the wait times. We have that, that information. So we have one way we can reduce this write delay durability that impacts the performance, that impacts that can leads to data loss if there is a delay in writing into the transaction log file, right? So that is where we would don't enable, but we will talk like if there is any other way, or is it so expected to have that write log, right? So we will talk that, right? So I'll stop here. Any questions? So I was asking like what are all weight types that you see? Like I know that whatever I mentioned. So any weight types that you notice in your day-to-day life, right? So we must have uh, reviewed the performance and all, and you might have identified some weight types, like you have worked some weight types. So any weight types that you have worked or that you are aware of. I need top 5 weight types that you know.
CS packets, page latch, page IO latch, resource semaphore.
HADR sync rate.
Normal.
Sync commit, semaphore. Okay, interesting. Semaphore. Okay.
Async.
Async what?
Async IO.
Async network IO.
Async network IO. Okay. Any one
SOS scheduler yield.
SOS scheduler is typical. Like we always see that SOS scheduler yield. Okay, whatever. So SOS scheduler yield, right? So these are all a few things, right? So what about locking, so you'll see that there are many, right? Okay. So any one line answer for this? So one line answer for any of these that you have explained, right? So CX packet.
Parallelism issue.
Parallelism for the CX packet.
Okay. CX packet is parallelism. Okay, next. Parallel execution. What about okay? So page latch. What about this resource semaphore?
That's a memory, I think.
Correct. So this is for memory. Okay. What is this HDS sync commit?
Availability group.
Availability group. What do you mean? For all availability group, you see that HDS sync commit?
When there is an
Synchronization
issue.
issues.
Yes.
Sorry? What was that? Go on, one by one. Anyone.
when there is synchronization issues between the primary and the secondary replica in the availability group.
Right. So if it is a synchronous commit and there is a synchronization issue between the primary and secondary, right? Any idea what is this page latch?
I think page latch has to do with memory as well. Memory pressure
this?
reading from page IO latch will be with the disk, and page latch is more related to the memory.
Page latch is more related to memory. How?
So difficulty reading from the memory cache, from the buffer
Difficulty
cache.
memory. Okay. Okay. So yeah. So page IO latch. Whatever you said, like it is reading page from the disk, and only difference, right? Page IO latch is reading page from the memory. The page IO latch is reading page from the disk. Only difference, right? So, but page latch doesn't mean that there is a memory issue, right? So page latch, the page is available in the memory, and then it is reading the data page, right? So that is where it acquires a page latch, but doesn't mean that there is a memory issue if you see that page latch. But yeah, we will talk that, like, this is also one of the top 8 types. So HDR, what is the async network IO? Does it mean that it is a network IO issue? I mean, does it mean it is an issue with the network?
I think it's with the application.
Application what?
It's async IO is an issue with an application not sending requests as quickly as possible to interact with the SQL engine.
Okay, your point is valid, but if I take this, if I execute select star from sys processors where speed equal to 85, whatever. If I execute this and if I execute this, see, async network IO. So there is no application, nothing, right? So we have a SQL server. We have 2 sessions executing from within the same server, and I still see that async network IO, right? So async network IO is basically a client fetch. What does it mean by client? Client is nothing but your SQL server, right? Whatever client is not your application. Whatever you are fetching the data, client can be your application, can be SQL server, can be anything, right? So your client is reading some data, your application or some client, some session is your execution, you're executing a query, and we are reading data. And SQL Server has to fetch the data fast enough to get the result set, right? So that is where you will see this async network IO. So async network IO is basically SQL is not reproducing the result. Our client is not able to fetch the result set immediately to display or to process, right? So that is where you will see that async network IO, right? So it is not necessarily that there is a network issue, but there are chances that network issue can lead to this problem. But without any network uh, involved here, so within the same instance, I executed a query and I still see that async network IO wait times, right? So that because it is fetching more result set and SQL is not able to process the result set fast enough. So that is where you will see that async network IO. Async network IO is not always the issue with network. We will talk that how to reduce the async network IO wait times that we have. SOS scheduler yield. What is your understanding about SOS scheduler yield? What was your understanding and what is your understanding now after our discussion, about SQL operating system? SOS is nothing but SQL operating system. What is this? What is your understanding of SOS scheduler yield? Hmm? So what is your understanding? So SOS scheduler yield, basically thread is waiting for signal to be, the thread is currently in the runnable queue, and the thread which is in the runnable queue is waiting for the signal from the thread which is currently running, right? So until the thread is giving signal, then you will see it is waiting. It is marked as SOS scheduler yield. So see, it is waiting for SQL OS to schedule the thread upon yielding the existing thread, which is currently running on the CPU, right? So SOS scheduler yield is nothing, is always UC, because we spawn only certain threads, right? We will not spawn every thread to the Windows operating system. We spawn the threads and start executing, right? Based on number of threads that we have, and it spawn one thread, and remaining all threads will be waiting on SYS scheduler yield. So remaining all threads in the runnable queue is waiting on SYS scheduler yield, right? So that is what we have, right?
Okay, please, what's the difference? What's the relationship or the difference between CS packet and CS consumer? Can you explain that a little bit?
CX packet and CX consumer, I feel both are same. So starting from 2016, I think consumer concept has introduced, right? So I believe that both are same. There is no specific difference that we have. But so normally how parallelism works, right? Like let's say, for example, you have a parent thread created and you'll have a child thread created, right? So let's say, for example, you have some child threads. CX packet or CX consumer, right? So it's a kind of consumer that we have, right? So these are all threads which are executing, and let's say this thread, how the C how, this is the parent thread. This will be waiting on the CX packet, and whatever the child threads is currently waiting on CX consumer, right? So this CX packet, because all the child thread has to process their result set and will be sending it back to the parent thread to process, right? So CX consumer is, let's say, for example, one thread is depending on another, another thread is depending on another, another thread is depending on another. If one of the thread is slowed down, is not processing, and other thread has to wait for this thread to complete, right? So that like so every thread will be in sync, and then it will send the result set to the parent thread. So this will be waiting on CX consumer, a CX packet, and this individual threads will be waiting on CX packet. So that is my understanding, but normally I don't look like these are two different things, right? So but starting from 2016, like I think there is some internal structure which has divided as a CX consumer and CX packet, but both are related, so each other. And whereas like CX packet or CX consumer, if you see, and these are uh, the high level difference, right? So the parent thread is waiting for CX packet, and CX sync or CX packet sync, we see, and the child threads which are in the, so waiting for consumers thread, consumer or CX consumers that we have. That is the high level, right? So based on my understanding, but I'll see like if I have any better way of, so giving, so I'll tell you that. Okay. So any questions? I think I am late. Like any questions that you have, and so that we can discuss. So I'll share the scripts that what we are executing. I'll share in the Git repo, or even Shanmugh has, like he will share, like either of us, like will share that Git repo, and so that you can access the scripts and the so queries that we have.
Yeah, but
Hmm.
are you going to talk about more of the other weight types when we're discussing, or the ones based on the ones you have on the slide?
What was that? Like you're asking, like these are all.
Like, are you going to discuss more of
Yes.
further weight types apart from the ones we have on the slide? Because at work, I basically see a lot of weight types, like things I don't really understand. Though you explained,
No,
there was
so
something
I
you
will not
explained.
explain all the weight types because few weight types you don't need to even worry or consider, right? So, for example, CLR weight types. So, CLR weight types is expected to see if you are especially using some .NET or even SQL Server internally uses that common language runtime, right? So, CLR in the SSMS code. So, because SSMS is basically developed using the .NET. So, these are all common while so checking that. But I'm not going through the complete weight types, and we see that what are all weight types impacting weight types, right? So if the weights are actually impacting the system, so that is where you will have to look into, right?
Oh, okay.
So if
Okay.
anything additional, right? So maybe I would suggest, let's say for example, I will show you that.
Let me give you an example. If you see, like, I sometimes I see preemptive OS.
What is that?
Sometimes I see weight types like preemptive OS. But I know you talked about that a little bit yesterday. But we need to go. We need to go over the video.
uh,
Preemptive OS.
Preemptive.
Preemptive.
Preemptive,
Yeah.
okay. No, yeah, again, like, so those you will not, you don't need to worry. Like, for example, if you talk about preemptive, so weight types. Okay, let me have this here. Um, Select star from sys.dm underscore voice underscore weight stats where type weight type like preemptive. There are preemptive many things, right? Like if you take anything, like for example, preemptive, okay, whatever, right? So you'll have something called SQL skills, and let's see if it is loading or not. It never loads. Okay. Hmm. So if I take this search with preemptive, whatever it is, so it says that internal users, right? So it is not something that so you will have that very so detailed explanation, or even it is not impacting anything. So if you have access to so if you open the SQL skills, right? So SQL skills was so developed by so the SQL skills is some Paul Randall, like he gives everything, right? Whatever weight types that we have, so he developed few of them. So you can see it, they mention he clearly mentioned that it is not impacting weight types, and you ignore the weight types, right? So that is where you have. So whatever weight types that you have a detailed explanation or information, that is where somewhat so impacting to the queries or the execution. But whatever you have this internal, like, or whatever we have it here, the preemptive and all. So this is just an internal users. The SQL Server internally will take care of that, and you will not have any impact of that. So we cannot just so keep talking about so weight tabs, because this will not have the detailed information, and you would not be able to so you we would not see any direct impact to any of the queries, or any impact to the execution of your queries, right? Even along with the CLR, right? So CLR, for example, CLR join whatever it is and waiting for another task to end. This wait stats occurs when there is a join between tasks, right? So CLR joins and all. So if any of this specific CLR, maybe we'll have to look into that. So I can give you the reference, right? So maybe you can go through whatever, like, so even in the SQL skills, I think that is not that is opening, but either you can go to SQL skills or the Microsoft articles, or to understand what is that. But only I can tell, like, if there is an important and impacting to the queries or the SQL execution or performance impacting wait types, not everything. Right? So we have, if I talk, like, we have around 800 or 700 plus weight types, right? So including aggregate, like, at least you will have the 200 plus weight types. Even I don't know most of the things, right? So we never worked on anything. Like, if you see that even internal, it is not taking anything, like weight tasks, like nothing, right? Even if you take this, like, it is not nothing, right? So those are all not. So we will talk only a high level, which are actually required and impacting the business.
Yeah, I'm asking this because I need to clear my doubts, And another weight type I usually see is broker receive wait for.
Hmm.
So when I see that, I usually ignore it, but I don't know the reason why I have to ignore it. So what can you explain that?
So it's internal weight types, right? Like, for example, you have a any so broker weight type is nothing but, like, for example, you have an internal mechanism, internal queuing algorithm. So it will be a queue. So you'll have a queue. So whereas it will be loading that buffers in the queue. So while processing, so that is where you will see that uh, the broker weight types or service broker, whatever it is, which internally uses that, right? So even that we don't even consider, like, so it's a majority weight types that we have. So broker weight type is basically, like, it is internally using the service broker to process the queue structure or queuing of our data. So let's say, for example, you have a always on. So even always on processing the data, right? So that will be inserting into a queue to process the data before it is processing the data. So that is the internal queuing. It will be inserting into a queue and process the data. So that is where we don't see any wait types, right? Your query is not User queries will not be waiting on any queue broker wait types, right? So that is the internal structure. It is waiting on the broker wait types. So that is continuously you will see.
Okay, but I usually see that with read DB mail
DB
sometimes.
mail, okay, correct. So DB mail is one of the queue, right? It is a queue structure in which has to have that queue, and then it will be sending. So that is where you will see that queue. That is where you
Okay,
will see that
when
queue.
when it comes up, I mean, I should just ignore it, right? Basically.
Correct, correct.
Okay.
That's what,
Another
right?
one, the other one I want to ask you about probably might not be much related to the weight type is I usually see that as well. I ignore it, but I don't know why I should be ignoring SP read request.
SP read request as a wait. What is that?
Yeah, I usually say it on, when I see it on the monitoring tool, I like when I go into to see what's going on, I notice that probably it's using a third-party application.
Hmm.
But when I've tried to dive a little bit deep to understand that, but
Hmm.
I was
What is
I
the
was
wait
just
type?
told
You are
to
talking about CLR.
read request,
CLR read request.
SP read request. Now, when I see that, I usually ignore it, like it's not impactful, but I don't know why I have to do that.
I don't even know what is that wait type. SP read request. Okay. Is it specific? Is it wait type, or is that the query that you are executing something
I
and you
think I think I think it's a query or something like that.
I don't know. Okay. Long running process error due to okay, database mail. Again, I think it is a database mail. Read Read request. Okay, in order to read messages from the queue. Again, that is again like that is kind of service broker queue, which is reading the data from.
Oh, okay.
Yeah,
That makes
I
sense.
think this is you can ignore.
Oh, that makes sense now. Yeah.
Yeah. Okay. Cool. So I'll stop here. Any questions? So we will talk, so detail like few at least, so that weight types, and so that you will understand the basic that how to investigate, how to start troubleshooting for weight types that we have, right? So maybe you'll have a better understanding about that weight types. Not every weight type, but if anything specific or one of weight that you'll have to investigate, maybe you can go through the Microsoft article or even SQL skills, right? So I can give you that is better resource for the weight types. I cannot open, sometimes I cannot open the SQL skills. SQL plus weight types. Whatever, right? So it's just not taking to. Fine. Okay. So any questions? Cool. So I'll stop here. So you can go through that. This is never I don't know, like some issue with SQL skills or not my network. I don't know. You can go through it, so SQL skills. So if you just put that like whatever weight type that you notice, either broker whatever, so you can just use that and use SQL skills so that you will get that, right? So if I take that broker, right? So broker dispatcher, like whatever the endpoints restart or whatever, like so you have. So these are all the things, right? But if you are using service broker, right, external service broker, if you are using that, you might have that, so huge queue is processing. That is where you will have that, so high waiters. That in that case, maybe something that we'll have to check or we can ask developer to validate the service broker that they have the logic to process the service broker queue. Because if you have a high transmitter and high service broker processing or the queue processing, then we will have to check that further. Or we as in like you can ask application team or developer team to look into that. Right. So okay, I'll stop here and then we'll so I'll ask Shanmugh to share the recordings and we'll work on, and I'll share that, so I'll or Shanmugh will share that Git repo for you to access. Okay, so I'll stop recording here.